Hey, seventh grade, week 16, and we're talking about geological processes. Today, I want you to be able to explain faults. So, as we look at this, somebody might look at this and think that that's a river, but actually, it is a lake. It's a very long and straight lake. This is known as Crystal Springs Reservoir near San Francisco Bay Area. The water has collected in a low point in the land. The reason for the low point is a fault, specifically the San Andreas Fault. On one side of the reservoir is the Pacific Plate. On the other side is the North American Plate. Would this be a good place to build a home? I don't know. A rock under enough stress will fracture. There may or may not be movement along the fracture. If there is not movement, the fracture is a joint. If there is movement, the fracture is a fault. So, is this a joint or a fault? Well, we just told you this is the San Andreas Fault. So yes, there is movement and it is a fault. Let's talk about joints for just a second though. If there is no movement on either side of the fracture is called a joint. The salt rocks in Asia show horizontal and vertical joints. These joints form as the lava cooled and then contracted. Faults, on the other hand, do have movement. If the rocks on one or both sides of a fracture move, the fracture is called a fault. Faults can occur alone or in clusters. A cluster of faults create a fault zone. Earthquakes happen when rocks break and move suddenly. The energy released causes an earthquake. Deep slip faults. Slip is the distance rocks move along a fault. As one block of rock moves past the other, the angle of a fault is called the fault's dip. If the fault dips at an angle, the fault is a dip-slip fault. Imagine you're standing on a road looking at the fault. The hanging wall is the rock that overlies the fault. The footwall is beneath the fault. If you are walking along a fault, the hanging wall is above you. The footwall is where your feet would be. Miners often extract mineral resources along faults. They used to hang their lanterns above their heads. That's why these layers were called the hanging wall. So block A is the hanging wall, and block B is the footwall. The left diagram shows a reverse or thrust fault, and the right diagram shows a normal fault. Normal faults, the hanging wall drops down relative to the footwall. Normal faults are caused by tension that pulls the crust apart. This causes the hanging wall to slide downward. Normal faults can build huge mountain ranges in regions experiencing tension. These are the Sierra Nevada mountains in Eastern California, and they rose up along a normal fault. Thrust faults. When compression squeezes the crust into a smaller space, the hanging wall pushes up relative to the footwall. This creates a reverse fault. A thrust fault is a type of reverse fault. With a thrust fault, the angle of the fault is close to horizontal. Rocks can slip many miles along these faults. In this particular thrust fault, the rock on the right is thrust over the rock on the left. The rock on the right has also started to fold because of this movement. You can see the fault line running from about the middle of that crowd and then you follow it up and to the left. So that if you were to extend that line all the way from the middle of that crowd to the tree that's the furthest over on the left, you'd have a line in the rock right there. You can almost see it. Hopefully you can. A strike slip fault is a dip slip fault where the dip of the fault plane is vertical. Strike slip faults result from shear stresses. If you stand with one foot on each side of a strike slip fault, one side will be moving toward you while the other side moves away from you. If your right foot moves toward you, the fault is known as a right lateral strike slip fault. If your left foot moves towards you, the fault is a left lateral strike slip fault. The San Andreas Fault in California is a right lateral strike slip fault. It is also a transform fault because the San Andreas is a plate boundary. Unlike what some people think, California will not fall into the ocean someday. The land west of the San Andreas Fault is moving northeastward, while the North American plate moves southwest. Someday, millions of years from now, Los Angeles will be a suburb of San Francisco. And eventually, we may have the island of California. So, in summary, a fracture with no movement on either side is a joint. A dip slip faults show vertical movement. In a normal fault, the hanging wall drops down relative to the footwall. The reverse is true of a reverse fault. Strike slip faults have horizontal motions due to shear stresses. And perhaps the most famous strike slip fault is the San Andreas Fault. Okay, if you feel that you can explain faults, then by all means go on to the questions. If you need more time, please go back to the video and make sure that you take down some notes before you do the questions. Have a great day, and we'll talk to you again later. Bye now.